Hey everybody, today we're going to work our way through the introduction of a new function. This will be a function that you are responsible for. We're going to take it from the beginning and we will go through some common properties. This is going to be a function that you will be responsible for knowing very, very well. So let's take our time working through it, and then we need to get some practice to make sure that we can hunker all this stuff down. Okay, you see the equation to that function in both the title and the instruction for today. What we are going to do is graph the function y equals x squared on the axes below. So, up to this point, the way we can graph any function that we are not familiar with is to use our good old table of values. So, I am going to put down an x and a y coordinate, and we're going to use a couple key points. So, we were going to start with the easiest of easy, 0, and then probably 1 and 2. My suggestion to you, don't just stick with positive values. So let's pick some nice, easy negative values as well. Okay, what I would like you to do is very, very quickly go through, make those substitutions for x back into the function, and let's come back with our y values and our table completed. Okay, pause the video now. Okay, we're back. So a quick substitution of 0 in for x. 0 squared is 0. 1 squared is 1. 2 squared is 4. Negative 1 squared, make a note that what that says is it says y equals my base, negative 1, must all be put to the exponent 2. Do not confuse that with this. Notice the 1 is the base, not the negative. So if we're very focused on that, then we should be good. Negative 1 squared gives us 1, and negative 2 squared gives us 4. So we can go ahead and we can plot those points on our graph. We have 0, 0, 1, 1, 2, 4, but then we also have negative 1, 1, and negative 2, 4. Those are the points that I'm able to graph. I could extend my table a little bit if I wanted to see what would happen at 3, for instance. Now I'm going to end up getting my 9. You'll notice that 3, 9 puts us off the grid. Not exactly useful, but at least it gives us an idea of direction. I can connect those points that I see on my grid. Make a note. This is not me taking line segments and connecting. No. I would hope that when you take a look at those 5 red points, we recognize it's not a line. But I also want us to make sure that we're good on shape. I'm going to do one more substitution, and it's a value you would not have picked, and that's fine. I wouldn't have picked it either. But if I make a substitution of 1/2, then I'm going to calculate 1/2 squared. That's going to give me a value of 1/4. So just to move us away from the linear aspect to something, can you please take a look at my graph? That would be me, with a very crude line, connecting 0, 0, and 1, 1. You will notice, though, that what that line represents is a slope of 1. So if I move to the right 1, I move up 1. Actually, what it represents is whatever I move to the right, I move up. So the point 1/2, 1/2 would be on that line. Here's the problem. Look back at the table. 1/2, 1/2 is not on that equation, that function. I need to go to the right 1/2, but only go up 1/4. So if I was to get rid of that blue line and instead now plot that orange one, maybe I'm around there. I go to the right 1/2, but only up 1/4, and I'm hoping that we can maybe see that gives you a curve. If we were to continue that curve, actually, I don't really like that curve, I'll be honest with you. Because when I started to curve it, I started to almost make it wrap back around. And you'll notice if I do that, that's not going to satisfy that 0.39 that was floating up there somewhere. It's also not going to satisfy a function because we know a function has to pass the vertical line test, so I know it won't wrap back around. So I need to be very conscious when I draw that. As I go through and I come through that last point, keep getting wider and wider and wider, but I will acknowledge steeper and steeper. Same thing to the left. Curve up, and something like that. I'm just going to highlight my red points again, and you can see there is the graph of your base function, your y equals x squared. What you want to do is you want to take that graph and you want to burn it in your brain. We want to make sure that we are good with that. So the shape of that function, this soft little U shape, that represents what's called a parabola. Okay, it's a soft blah on the end, not bola, soft blah, parabola. And that is an example of a quadratic function. In fact, that is our base quadratic function. You'll notice it's quadratic because the highest exponent on our x is a 2. Okay, as I said, burn it in your brain. Make sure that it's automatic. What I want to do is spend the rest of our short video today talking about the properties of our parabola. Okay, let's jump right in. Okay, you'll see that all I did was just shift my graph over to the left side now, and on the right side is what you see on the bottom of your page. We need to go through and state the following properties. Now, a couple things. Some of these properties are going to be brand new to you, so we're going to need some definitions for them, some understandings of what they're talking about. Others, you'll know. Okay, let's jump right in on the first one, us talking about a vertex. When we talk about a vertex for us has always been like a hard corner. I really want to kind of move that back. If we're talking about graphing functions, then what we talk about when we suggest a vertex is a change of direction. So that is going from down to up or up to down. That change would be called a vertex. So when we talk about a vertex, we talk about change of direction. And you'll notice on that parabola, your change of direction is at the origin. It's at 0, 0. So what we need to do is burn in our brain our base function, our base quadratic function has a vertex at 0, 0. Okay, the next one, direction of opening. I think this one almost goes without discussion, or at least a very quick one. When we are talking about the direction of opening, you will notice that this parabola opens up. Okay, it's closed at the bottom, it is opening up, and it is getting wider and wider. Sometimes it might be easier by comparison. That would be a parabola that was opening down. The open side is on the down side, okay? So for our base quadratic function, our base parabola, the direction of opening is up. And you can see that on our graph. Okay, the shape. The shape is one that always drives me nuts. When I ask you for the shape of your parabola, do not tell me parabola. Okay, what we go from is a general understanding that we know that that shape is a parabola. And similar to our direction of opening, this can happen through comparison. What you see is the shape of our base parabola. What we're going to deal with over the course of this year, as well as every math course you take in the future, you're going to end up dealing with some parabolas that maybe are a little flatter, or are steeper. And so when we discuss the shape of the parabola, really what we're talking about is the slope of it. Like, is it a steep parabola? Is it a flat parabola? And so on. What you see in the blue parabola, our base function, our base parabola, is what we just refer to as a normal shape. That is a standard shape. It is normal for that parabola. Okay, now we jump into something called the axis of symmetry. I'm going to go ahead and I'm going to draw something on our parabola. This is not something that I ever want you to put on your parabola. It is one of the most useful properties we will have, though. I hope if you look at my parabola, you will notice that one side of my parabola is a mirror image of the other. And if I was to put this dotted or dashed purple line down the middle of that parabola, you may notice that if you were to take one side of the parabola and now reflect it across, so if I took this one red point and I put it the exact same distance on the other side, and then I did that for every part of my parabola, this distance, this distance, then my left side of my parabola becomes a mirror image of the right side of my parabola. When we talk about mirror images, we could then say that the one side of the parabola was symmetrical with the other side. When we talk about the axis of symmetry, then what we're talking about is the line that would be the line we would reflect something across to make it symmetrical. The axis then is my purple dotted line. That dotted line is what makes one side symmetrical with the other. So if I just got rid of all of that stuff that I just put on our parabola, then the axis of symmetry, since it is a line, it requires the equation of a line to be written. So that line that goes straight down the middle of my parabola, passing through the vertex, is a vertical line. And I hope we're good that all vertical lines take the form x equals, because the x-coordinate is the same everywhere along that line. So you could say like it's x equals c, where c is just a constant. Well, that axis of symmetry would be x equals 0 for my base parabola, because my vertex is at 0. So my dotted line would run every point that has an x-coordinate of 0. Okay. Take a look at the next one, max or min. When I ask you max or min, I'm going to eventually ask you a number of things. I will ask you, does it have a max or does it have a min? And then I'm going to be very specific and ask you, what is the maximum or minimum value? For this, I really just want to nail down the max or min component. So when we take a look at this parabola, I need you to know, does it have a max or does it have a min? Okay, I want to make sure we're good on what we're talking about. If you recall from our discussion about what it is to be a function, and when we ask what is the function's value, remember we are always talking about the y value. So if I was to ask you, does this function have a maximum value or a minimum value, we're talking about the y. Okay, I want you to look up at my parabola again, because there's something really important. Take a look at the top of that parabola. We put arrows on it because that parabola goes on forever and ever and never stops. That means that parabola continues to go forever. So if I was to ask you, does that parabola have a maximum y value? I hope you would say no. If it keeps going up forever, then there is no top. There is no maximum. But if I erase that green and we look on the other side, Does that parabola have a minimum value? And you'll notice that that parabola does not go below the vertex. It stops. It comes down, 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 then goes back up, up, up. It never goes below that value. So does it have a minimum y value? Yes. So again, if I got rid of all that green, what we have in this instance is a minimum. Okay, we're going to get a lot of practice working through that one. Okay, I want to jump into something that should be fairly straightforward. We're talking about domain and range. When we talk about domain, we are talking about all possible x values. I hope if I was just to jot down again as a reminder that the equation that gives you this function is y equals x squared. There is no restriction on what you could ever sub in for the base of a power, that x. If I'm putting an exponent of 2 on it, then there is no restriction. I can square any number. So because x is in the base, then x can be anything. There's your x as an element of the real numbers. Your range, well, if you take a look at the picture, you'll notice that your y values are never negative. They're always positive or 0. So your y values must be greater than or equal to 0. Just remember, I don't care if you ever write it that way or if you wanted to write it as 0 to infinity. Either way is good. Okay, those are going to be the base properties that you're going to need to know for your parabola. We are going to get so much practice working through those things, I think you're going to get really comfortable with it. Today is an introduction to those properties so that we can talk about them with a little bit of background when we get to some other things. Okay, quick run through of the most important function we're going to deal with this year. Okay, I hope it helps. We'll see it in practice later on.